Hi, in this demo I'm going to look at setting up the redsocks application on Kali Linux to enable any device on my attacker network easy access to any reachable device on a target network via a dynamic socks proxy. This has a number of advantages, such as not needing to use proxy chains, specify specific proxying options, and also enables me to use other devices on my attacker network, such as my Windows 10 VM, seamlessly to connect to these remote targets. So in this case, we've got a Kali box with an IP address of 10.66.10.201. This will act as our gateway box. We've got a Windows 10 VM on 10.66.10.56 and a target network reachable via an entry point that exposes a number of networks, including 172.16.1.0/24. This target network is the offshore ProLab on Hack the Box, and I would like to thank Mr. Ben for kindly agreeing to allow me to use these lab as part of the demo. So first of all, what we'll do is we'll connect to the lab. So I've created a specific account with certain privileges to enable me to do this demo, and in this case we're going to set up a dynamic proxy using an unprivileged account to a particular box on that lab. So next, let's have a look at the redsocks configuration. So what we're going to do here is set it up so that we can run it manually and see the results rather than run it as a normal daemon. So set debug on, redirect data to standard error. We won't daemonize it. What else have we got here? Default is to use IP tables. So what happens here is that the redsocks proxy will receive packets destined to it via an IP tables rule on that port and that address, and then forward it to our socks proxy. Now, an unfortunate issue with the redirect target on IP tables, which is the way we're supposed to configure this, is that the target interface that is used is determined by the originating location. So if we generate it on Kali, it will go to loopback, but if it's a transiting packet, say from our Windows 10 VM, then it will be the incoming interface of the packet. So if this Windows box is .56, sending it to our Kali box on .201, then the listening interface is 10.66.10.201. So whilst, as it clearly states in the config, loopback's best because it's, for security reasons, we really need to be listening on any or set it up in a slightly more complicated way, so we only listen on specific non-loopback addresses. I think that's it for this particular part. So yeah, got that there. So via IP tables, redirect will go to 12345, and then that'll forward it on via socks 5 to 127.0.0.1 on port 1080 even, which is this one here, and then it'll carry on to the rest of the network. I think that's it for this bit. Next, we need to set up so enable forwarding. In real life, we'll clearly add additional rules to ensure only the authorized forwarding is allowed. And now we need to set up our redirects as specified. In fact, what I could do is show you something. So this is the GitHub page for redsocks. It's got an example on how, a number of examples on how to set it up. You can have a look at it. One thing worth noting, which I've highlighted, is quite a lot of SOCKS proxy servers don't actually support UDP. So the in the RFC there's a UDP associate, which allows us to handle UDP, but unfortunately SSH doesn't support that, so we don't directly support UDP over that particular SOCKS proxy. So you have to find other ways. So DNS, for example, they force it to fall back onto TCP. Let's clear that. So back to this, we've got IP forwarding set, so IP tables, it's in the NAT table, isn't it? So for local packets, it's going to go via the output chain. We're only allowing TCP, and destination was 2.16.10/24. Redirect to ports 1, 2, 3, 4, 5. And we do the same with pre-routing. So the pre-routing one will be for the external packets from, for example, our Windows VM. This has been redsocks. Yep. Config. So now we've got that set up. It's listening on so yeah. So we can ignore the UDP bit because we're not actually making use of that. But we've got max connections set to 128, so that's okay. Good. So let's just try. So you can see here we've got an accept. So that's now working. On the Windows box, because we don't normally have it going via our curly box on our routing table, we need to add that. 16.10.24.10.66.10.01. I've got Netcat installed here, so we can do the same quick test. And again, you can see it's come up here on our debug and info. Simple as that. So we've already now set it up, nice and straightforward. I did want to take this a bit further, so at present we're listening on any. What would be nice is if we can listen on loopback and still be able to do this external routing. The later version of redsocks on UDP supports the tproxy target on IP tables. This doesn't have the constraint of the way it chooses its interface. Instead, it will forward it to a specific IP and port, and also not alter the packet. Unfortunately, it requires let's see, where is it? It's that one, yeah. So it requires certain socket options to be set by the application. Fortunately, though, it's open source software, so we can change it ourselves. So this kernel documentation shows us a way of setting it up. But the key thing is that we need this transparent option set. So if we go to an already downloaded version, I think it's in utils if I remember correctly. Yep, here we are. Actually, that's not. Yeah, that is the bit. So at present, so for the demo, I'm just doing it in a more of a brute force-ish way. So this generic part of redsocks is the bit that actually does the bind, does a reuse address as you would expect with most listeners. So what we need to do is 1, 2, 3, 4, 5, 6. Duplicate that and set sol IP and IP was a transparent, wasn't it? IP transparent. So if we set that up, the listening socket will now open correctly with the correct options to receive a packet from a tproxy redirector. The other thing worth noting is this bit. So in redsocks we have this redirector. So IP tables, depending on which distribution you're using, IP tables is default, but also generic. If we actually look at the way redsocks does this, under IP tables it'll actually ask the kernel for the original destination, but because tproxy doesn't alter the packet, if you then look at the generic one, it just takes the destination address. So generic becomes the more correct option, shall we say, for this way. So in theory, just by adding that set option in the previous C listing and recompiling it, should be enough for the redsocks application to support what we're trying to do. So if we make that, so the usual warnings you get when compiling this type of stuff, but it all looks good. So offshore. So I've taken the slightly newer config from the downloaded version and updated that as well. So okay, so debug's off, but I've still got a std error set. And now I've changed the redirector to generic. Local IP now is 127.0.0.1 rather than any, but still using the same port. And then obviously we're going to the same SOCKS proxy, SOCKS 5 proxy. Okay, so if we clear that first. Good. So we've now cleared the redirects from IP tables. What we need to do now is set up some policy routing. In order to do that, we'll use IP rule add mark1 lookup 100. So what we're saying here is we're creating a policy routing rule where if the packet's marked with a 1, we'll use table 100 rather than the default routing table. And then what we say is IP route add local any address, send that to loopback. And we do that for table, we add that to table 100. So IP route show table 100. That's now added as a default route. We can now, actually what we need to do is, if I remember correctly, it doesn't normally install the kernel module. Table mangle. So we've now got the mangle table, which is where the tproxy target is used. And what we do now is we say IP tables in the pre-routing. So it's pre-routing or output, if I remember correctly. So output, obviously, if it's local, but we're not going to do it that way. Jump to the tproxy target on port 12345 on IP 127001, and importantly we need to mark it so that mark will ensure that we then use this policy route of going to loopback. And finally, we need to set a normal routing rule, because rather than just doing it for transiting packets, we're also going to do it for local packets originating from the Kali box. So in this case we're saying, again, for that specific network, which is the one we're targeting, obviously you would add whichever ones you need to, redirect that to loopback, and that should, again, with the in combination with that pre-routing rule and the policy routing, get us to relevant location. In theory, that is it. So this is our new redsocks that we compiled recently, and then we're using the new config. So that's started. What we could do is have a look here. So we can see here it's bound to loopback. Cool, that worked. And over here, do the same thing. Again, you can see in our information on the actual application it's coming through. And again, there you go, sorted. And just to be sure, let's try a few things. Should we just go back? How about that? Got a nice little flag there. If we now go over to Windows, let's create a password. Convert to secure string. We haven't copied it properly, have we? That's better. Okay, what went wrong there? Ah, yes, I know what I've done wrong there. Try you instead. And again, we can see the redsocks client coming through here, which is good. good. Let's just try one more thing. Net use hcolon local. Should do it market local. Hopefully the password's still in my buffer. Yep. And again, we see another one come through. So we've got a flag there as well. And yeah, so yeah, so we've got basically here we've got our Kali box talking to 172.16.1.101, and we've got our Windows box talking to 1066.101 and also 1066.1.5 via our redsocks proxy. All nice and easily, no config options in terms of specifying SOX proxies on any of those additional commands. The only disadvantage at present is that there doesn't seem to be easy ways to support UDP other than, I mean, the DNS one's quite useful obviously for a number of reasons, but obviously we do have the other ones, so I'd be interested to find out if anyone's got any easy ways to solve that particular problem other than writing some other code. But yeah, there you go. Hope you'll find that all useful, and see you next time.